Hey pre-calc students, this is Ms. Carranza, and today I'm going to be going over a lesson on how to graph exponential functions. And we will be expecting you to be able to do this without a calculator. Okay, so before you see the transformed equation for an exponential function. So this is not a parent function. This shows some translations and reflections possibly. So I'm going to go over what all these numbers mean. Notice that according to the rules, an exponential function has x as the exponent. Okay, so notice that the variable x is part of the exponent. It can have a multiplier out in front, and whether it's positive or negative will affect whether it's reflected over the x-axis. Now, the base has to be greater than 0, okay? And that multiplier in front can't be 0. So the multiplier in front can't be 0, the base has to be greater than 0, and it can't equal 1 either. If all these three things are true, where the multiplier a is not 0, b is greater than 0, but not equal to 1, then the graph will always be an exponential function graph. Okay, now let's say that we have a multiplier that is negative out in front. Okay, so if a is negative, that means that it is reflected over the x-axis. Okay, reflected over x-axis. And that means you have to change the signs of the y values. Okay, now how come? Well, remember, oops, I totally just did that backwards. Okay, if you have an ordered pair like 2, 3, and it's reflected over the x-axis, then it would just end up dropping down. So if you start with 2 positive 3, you'd end up with 2 negative 3. So that's how reflection over the x-axis works. Okay, so that's why the y values change. All right, now if a is positive, then you don't have to worry about changing any of the signs. Okay, so that's considered a multiplier. Now, if your x value is negative, okay, so if there's a negative multiplier on the x, like a negative 1, then that means that there's a reflection over the y-axis. And when you reflect something over the y-axis, so take that original point 2, positive 3, it would end up at negative 2, 3. So the y value would stay the same, but the x value would change signs. Okay, so reflection over the y-axis means that you change the signs for x. This is exactly the same idea as we studied in Unit 1, in Semester 1. Okay, so the idea of reflections and so on and so forth. So the outside multiplier is a reflection over the x-axis, and the one in this case that's the inside the exponent, that would be a reflection over the y-axis. Okay, now h is going to be your horizontal shift, as it always has been on any other function that we've talked about. And last but not least, k is your vertical shift. Now remember, horizontal shifts, you always take the opposite. So if you see a negative, that actually means to the right. So feel free to write yourself a little note, okay? And then the vertical shifts, those don't trick you. So if it's a +3, it means that it got shifted up 3. Now, one of the things that's really important for you guys to understand is that exponential functions always approach a specific value, and it's k. So they have asymptotes. In this case, they're horizontal asymptotes. Remember, asymptotes are invisible lines that aren't really part of the function. They're just represented with a dashed line, and your function always approaches it but will never intersect it. So horizontal asymptotes always depend on that value. So horizontal lines always start with y equals, and then k, whatever number you have for k, your vertical shift. That's going to be your horizontal asymptote. Okay, so go ahead and pause the video and think about all that. And when you're ready, you can go ahead and start looking at number 1 and ask yourself, what translations and reflections does number 1 require? It might not be obvious, so just try it, pause the video, and then we'll go over it and explain it. Okay, now for all of these functions, what we're going to ask you to do is identify the parent function. So we're going to ignore all of the transformations and reflections at first when we start doing our table of values. And then once we have those basic points, we can plot them once we move the origin. So again, this is very much related to the lessons that we learned in semester 1. Okay, first things first. In example 1, we've got f of x equals 2 to the power of x minus 4 minus 3. There's no negative multiplier out in front, and there's no negative multiplier with the x. So there are no reflections, which means we will not need to change the signs for x or y. This has been shifted right 4 though, because it's got x minus 4. Remember, that means you're always going to do the opposite. I know negatives are usually on the left, but that actually means you're going to move to the right 4. And then this guy over here means that we're going to shift down 3. Now, one thing that I do want you to make sure you label is the horizontal asymptote. So the horizontal asymptote is an equation that's always y equals, and it's based on that vertical shift number. So -3. Now, don't worry about the domain and range yet. We'll be able to do that once we have our graph, because notice that the directions do ask for domain and range. Okay, so I've done the first part, identify the transformations, identify the asymptotes. Now, in order for me to do the domain and range, I need the graph. So here's the process. Think back to semester 1, unit 1. We would look at the parent function, which is the basic form of this transform function, and we would create our basic points, and then we would move the origin. I used to call it the new origin, in order to graph the function. So the parent function of this is just y equals and then whatever the base is. So in this case, we've got f of x equals 2. Yes, it's got that x minus 4 and minus 3, but we're going to just consider y equals 2 to the x. Okay, so that's the basic parent function. You can also just call it f of x equals 2 to the x. Okay, now if I substitute -1 into this function, so I'm going to do all this work kind of off to the side, okay? 2 to the -1st power, okay? I don't know if you guys remember this from previous years, but if the exponent is negative, you need to drop it. So this would become 1 over 2 to the 1st power, which is 1/2. These are properties of exponents. Remember, these are exponential functions. Okay, 2 to the 0 power. So think back to freshman year when you learned about exponents. Anything to the power of 0 is actually 1, not 0. If you don't believe me, you can check it on your calculator later. And then 2 to the 1st power is 2. So notice what I did is I took all of these x values and I substituted them for x in the parent function. Okay, so those are the ordered pairs that I'm going to plot after I locate my new origin. So my new origin is going to be 4, comma 3. So my new origin is 4, comma negative 3. So we need to go 4 to the right. That's going to be where my x-axis goes, and then negative 3. Okay, so those are the new location of my origin. So 4, negative 3. And then from there, I can plot my ordered pairs, which are from 4, negative 3. I'm going to plot negative 1 and positive a half, 0, 1. I'm going to do it in red. And 1, comma 2. Now, exponential functions, do you see how it's rising as I go to the right? They're curved. Now, on the left side, it's going to look like it's flattening out, and it'll get really close to that horizontal asymptote. I'm going to go ahead and label it y equals negative 3. But your graph cannot intersect it, so make sure that you never draw it so that your curve intersects that. Okay, so now I should be ready to identify the domain and range. This function goes forever to the left and forever to the right because it's getting wider as I move to the right. The range, the lowest that it'll go is that negative 3 on the y-axis, but it'll never intersect it, so you cannot use brackets. Remember, brackets are only if your function actually intersects that value or has included in its table the negative 3. All right, and then it goes forever up. Okay, go ahead and pause the video if you need to catch up with any of the work and push play when you're ready. Okay, for number 2, first thing that I'm going to do is I'm going to identify any translations or transformations. So the first thing that I notice is that there's no multiplier out in front of the base, but there is a negative multiplier with the x. Okay, so think back. If there is a negative multiplier in front of the exponent of x, then that means that it's a reflection over the y-axis. And that means I need to change the signs of x values. This is something you're going to have to dedicate some time to memorizing or putting it on a note card and having it accessible to you so you can always look at it when you get confused, okay? So a reflection over the y-axis is when there's a negative multiplier with the x, and it means you're going to change the signs of x, okay? Okay, there's no number added or subtracted, so there are no horizontal shifts, but there is a vertical shift up 1. That means that my new origin is going to be at 0, 1. 0 because there were no horizontal shifts, and 1 because it was up 1. Remember that your horizontal asymptote, so I'm going to start abbreviating it with HA. Horizontal asymptote is a horizontal line that is based on your vertical shifts, and it's a dashed line that your function approaches but never intersects. So I'm going to go ahead and draw that line. And my new origin is going to be 0, 1. So notice that the x-axis didn't have to move because we did not have any horizontal shifts. Okay. All right, now the parent function is just y equals 5 to the power of x. So in your parent function, you're ignoring any reflections or translations. You're just taking the base, which is that big number, and then a 5, and then you're going to write down the exponent x. Okay, so now I'm going to take turns substituting these x values into the function. So 5 to the negative first power, 5 to the power of 0, and 5 to the power of 1. You get 1/5, 1, and 5. after you do that, you need to make sure you don't forget, and this is really important, any reflections. So I'm going to highlight it because this is one thing that a lot of students forget to do. Remember, this was reflected, so I'm not going to plot the points that I have right now on my table. I need to make sure I change the signs for the x values first. So I'm going to go ahead and change the signs. Let me do that in orange. Okay. Don't change the signs for your x's or your y values until you're done filling in your table for the parent function. Okay? Okay, so now I'm going to go ahead and plot those points using my new origin. So my new origin is at 0, 1. So from there, I'm going to go right 1 and then up 1/5, 0, 1, and -1. So that's left 1, up 5, -1, 5. So notice that this curves on the left side versus the right side, as in number 1. And then as it gets closer to the x-axis, you want to make sure that you show that it's getting close, but it will never intersect. It's an asymptote. Okay? So your function approaches the y value of 1, but it will never intersect it. Don't forget that they did ask for the domain and the range. So this function goes forever to the left and forever to the right. All exponential functions do that. They get wider as you go to the left and wider as you get to the right. So you'll see the arrows always point forever to the left and forever to the right. But the range is limited because of the horizontal asymptotes. So this one, the lowest that it goes is 1. And the value of 1 is not included because your function will never actually touch or have any points with a y value of 1. It just will get really close to it. And then it goes up forever. So remember, when you're giving domain and range, you always want to write your answers from lowest to highest. So quick reminder, always try to do the, write down all the transformations that you see, any translations or reflections. Then you're going to do your parent function table of values. Then you're going to change the signs if necessary based on your reflections. And that's when you finally plot your points on your graph based on your new origin. Okay? So there's a process. Okay, so take a minute, look at number 3, and write down any reflections and translations that you see in the function. So pause the video and then push play when you're ready. All right, so what I'm doing is I already completed the list of changes that I saw or transformations. There's a negative multiplier in front. That means I'm going to change the signs for the y values because that's a reflection over the x-axis. There's a horizontal shift, left 2, and a vertical shift of down 6. That means that my new origin will be at -2, -6. So I'm going to move the x-axis left 2 and the y-axis down 6. So that -2, -6 is my new origin. Feel free to use a highlighter if you guys want for the new place of the origin, or the x-axis and y-axis. Okay, now the parent function is going to be just 1/4 to the power of x. Now I'm going to take turns substituting -1, 0, and 1 into that parent function. I'm going to do my side work. So 1/4 to the -1st power, 1/4 to the 0 power, and 1/4 to the first power. So anything to the power of 1 stays the same, right? So 1/4 to the first power is just 1/4. Anything to the power of 0 is 1, not 0. And 1/4 to the power of -1 means that so if you have a fraction with an exponent that's negative, you're technically supposed to distribute the exponent to both pieces, the numerator and the denominator. And then remember, if the exponent's negative, you got to move the number. So if it's a numerator, move it to the denominator, and if it's a denominator with a negative exponent, you move it to the numerator. I would highly recommend that if this is the part that's making you confused, the properties of exponents, that you take some time, either Google it, YouTube it, Khan Academy, look up what the properties of negative exponents are, and refresh your memory. So the answer becomes 4/1 or just 4. Now, before you graph these, and this is really important, there was a reflection, okay? There was a reflection, so you need to make sure that the reflections are taken care of in your table. So if something is reflected over the x-axis, the y values change. So I'm going to go ahead and change the values to their opposites, change the signs, okay? And now I can plot those ordered pairs. So it's from the new origin, left 1, down 4, 0, -1, and 1, -1/4. And remember, it's curved, but your function gets really close to the asymptote, but it will never intersect it. Sorry, there's something on my screen that's keeping me from drawing this arrow correctly. Give me 1 second. I got to fix it because it looks curved. Okay. Okay. Now you can identify the domain and range. So the domain for all exponentials is always going to be -infinity to infinity, but the range is limited because of the horizontal asymptote, which I just realized I forgot to write it. So the horizontal asymptote is based on your vertical shift, which was down 6. Okay, now notice, -6 is the highest value on this function. It doesn't go any higher than -6. So when you're writing your domain and range, the higher value needs to go on the right, and the lower value needs to go on the left. So the range is -infinity to 6. Make sure you're not writing it 6, -infinity. Some of you guys used to do that first semester, but hopefully you're older and wiser and won't do it anymore. Okay, go ahead and pause the video if you need to. Again, if you're struggling with the idea of the exponents, you will definitely need to do some research on your own about the properties of negative exponents and zero exponents. The good thing about math classes is that a lot of topics build on each other. So if you learn something in one lesson and you learn it well, it'll probably help you in future lessons. So as you guys can tell, this talk about reflections and shifts and so on, and parent functions, that we've done many times before in semester 1, and now we're seeing it again. Okay, go ahead and pause the video and write down any reflections or translations that you see in example 4. Push play when you're ready. Did you see that there's a reflection over the x-axis? So you have to change the signs of y. Hopefully, if you did, good job. Did you notice that there was also a reflection over the y-axis, which means you also have to change the signs of x? Now, if you didn't catch that, I want you to notice that 3 minus x is not written in correct order. So 3 minus x is really supposed to be -x plus 3, which if written even more properly, we did this first semester, factor out the negative, it would look like this. So this is something that we've talked about since semester 1 in unit 1. 3 minus x is not written in standard form. It's the x is negative, so you write it as negative x plus 3, and then you factor out the negative to be able to identify reflections and shifts. Sorry, what this ends up meaning is that there's actually a shift to the right 3, not left 3, and then up 2. That creates a new origin at 3, 2. So I'm going to move the x-axis 3 to the right. And then the y-axis up 2. So my new origin is 3, 2. My horizontal asymptote is going to be y equals 2. Remember, it's based on your vertical shift. So in the previous problem, it was y equals negative 6. Here it's going to be y equals 2. That's going to affect the range, how high and how low this function is going to go. All right, now the parent function of this transform function of negative 4 to the 3 minus x power plus 2 is just y equals 4 to the x. So I'm going to take turns substituting those x values that were given to me. Remember, you don't change the signs until you're done with this part. So I'm just going to take the basic negative 1 to 1, and I'm going to substitute them into that parent function. 4 to the negative first power is 1/4. 4 to the 0 power 1, etc. Now I'm going to go ahead and change the signs. Now I have to change the signs for all of them, not just the x's, but also the y's. Now I'm ready to plot the points. So from my new origin, I'm going to go right 1, down 1/4, 0, negative 1, and negative 1, negative 4. Remember that your function approaches the asymptote, but it doesn't intersect it. Make sure you're not drawing it. I'm just going to kind of give you an example. Make sure you're not drawing it like this, okay? So exponential functions don't curve back up once they start dipping. So they have a flat area, they have a flat section, and then the other part is curved. So make sure that you're not curving this back up. I get that once in a while. Students curve this back up. It's not like a parabola, okay? All right, last but not least, the domain. That's your freebie. Negative infinity to positive infinity. And the range, notice at this point there's an arrow pointing down forever, but it's got like a ceiling. It's the highest it can go is 2. All right, guys. As always, if you have any questions or need any extra help, feel free to send me a message on Remind or ask your teacher for more help. Have a good day, guys.